Rocket League combines soccer with driving in a physics-based multiplayer game.
But how physics-based is it?
Psyonix, the developers for Rocket League, have tried to implement real physics, but it failed in the esports community.
Video games, especially esports, rely on predictability, which can prove to be a challenge with more realistic physics.
So just how real are the Rocket League physics?
This is just a disclaimer. This is a video game, so measurements including distance, time, and speed are all very difficult to find. We used approximations and the numbers given to us by the developers. So the physics may not be the most accurate, but we have made our calculations using the most efficient and accurate methods we could.
There are certain figures involving physics in Rocket League that are already given to us by the producers of the game, such as the fact that gravity is 6.5 meters per second squared, differing from the 9.8 meters per second squared in real life on Earth. The top speed of the car is 2,300 Unreal Units per second, which is equivalent to 82.8 kilometers per hour or 51.4 miles per hour. The top speed of the ball is 6,000 Unreal Units per second, which is equivalent to 216 kilometers per hour or 134 miles per hour. There are two different theories describing the field dimensions. One is that if the cars are life-sized, then the field itself would be quite large and would end up being over the size of an average soccer field. The other theory is that everything is minimized, and so the cars are tiny and so is the field. So we decided we would try and figure out what these field dimensions would be using kinematics. So the game developers of Rocket League have already devised an estimate for the scale and size of the field based on the Unreal Units. However, with physics, we can find out the actual scale. And Rocket League has some special features that make setting up this experiment easy. One of these features is that there's a clock that doesn't start until the time the ball is hit and stops when the ball crosses the goal. The other is that the velocity of the ball when it crosses the line of the goal is shown. As long as the ball is in the air, there should be no acceleration due to friction. So, using these features, we could hit the ball directly into the goal from halfway point and record the velocity and time. And with this, use the equation velocity equals distance over time to find distance. By conducting several tests and averaging out our answers, we figured out that the velocity of the ball when it hits the goal is 91 kilometers per hour, or 25.37 meters per second. We found out that the time on average was 4 seconds, and using the formula velocity equals distance over time, we found out that the distance from half field is 101.1 meters, and that multiplied by 2 is 202.2 meters, which would give us the length of the full field. So to find a conversion factor from our metric system to Unreal Units, we took the field length we found and divided it by the field length that was given to us by the producers, and got 0.0196 meters per Unreal Unit, which would be equivalent to about 2 centimeters per Unreal Unit. However, the conversion factor that the game put out was that 1 centimeter equals 1 Unreal Unit. Now this is only one example of a fallacy in physics in this game.
So I looked it up, and the average soccer field is 100 meters long, but we found out that the field in Rocket League is actually about 200 meters long, so the field is twice as large. And the developers have told us that the car is 144 Unreal Units long, so we use the conversion factor 1 Unreal Unit is equal to 0.0916 meters. We found that the average car is 2.83 meters long, but the average real car is 4.5 meters. So the game car is a little over half the size of a real car. So the field is very large based on the size of the car. This makes sense because to be boosting across the field, there would need to be a lot of space.
The next example of the game Rocket League using unrealistic physics comes to play every time the car hits a ball, another car, or almost anything. Rather than bouncing off what appears to be the physical dimensions of the car itself, whatever is interacting with the car will hit this thing called the hitbox, and thus never actually comes in contact with the car itself.
We know that the hitbox is a flat box, but it has been observed that when driving under a still ball, the ball moves backwards. This should not happen because if the hitbox was truly flat, the ball would either be pushed forward or it would not be moved at all. At first, it was assumed that this happened due to suspension wiggle, but with computer testing, it was shown that the real cause is a tilted hitbox. So how does a tilted hitbox, or any hitbox, affect vectors? Normally, vectors work based on the angle that the ball hits the car. So, if the ball bounced straight down on the car, it would then bounce straight up. It would keep the direction based on x and y components. So, for example, ignoring other forces such as friction, the x component would always be the same, and the y component could change because of acceleration due to gravity. Without the outside effects, the bounce should be at equal and opposite angles, according to Newton's third law. But when hitting the ball on certain places of the hitbox, specifically the edges or vertices, the direction of the ball can be unpredictable because it is hard to judge how the ball will hit the surface. So, psionics tweaked with it. Unlike real physics, Rocket League uses the center of mass of the car to the center of mass of the ball to determine the vector. This will judge the direction the ball will go.
In conclusion, Rocket League does not have the most realistic physics based on our calculations and knowledge.
But it does simulate real physics well enough to be intuitive and predictable for players. Rocket League's intentions were never to have physics as real as possible, but there are several aspects that make it seem real. Overall, I'd say the myth is busted. Special thanks to all the developers, pro players, and enthusiastic testers in the Rocket League community who made this video possible.
Most notably, Psionics Corey, Psionics Dave, and Rocket Science. Thank you for watching.